Part A of this question is drawing a velocity time graph for the journey. To draw it on the given grid. So we have a vehicle which begins at rest. So when t is 0, so time is the horizontal axis, we know v will be 0. So the graph begins at the origin. When t is nothing, v is nothing. It travels in a straight line. For the first 4 seconds, the vehicle moves with a constant acceleration. So for the first 4 seconds, we're going to see a straight line. And the gradient of that line will be 0.75. If it accelerates at 0.75 meters per second for 4 seconds, that means it will reach a speed of 3 meters per second. So think about 0.75 is how much the velocity goes up by every single second. So after 1 second, it's doing 0.75 meters per second. After 2 seconds, it's doing 1.5. After 3 seconds, 2.25. And after 4 seconds, 3 meters per second. So we can put the first part of our graph, a line going from 0, 0 to 4, 3. Make sure it is definitely a straight line. You must use a straight edge to draw that. For the next 5 seconds, the vehicle moves with a constant acceleration of negative 1.2 meters per second. So that means it's actually decelerating. If it does minus 1.2 every second for 5 seconds, that means at the end of the 5 seconds, the velocity will have decreased by a total of 6 meters per second. So it's going down by 1.2 every single second. So now we can draw the next part of our graph. So the next 5 seconds, so this is going to go up to a time value of 9. At time of 9, the velocity has gone down by 6 altogether. So that means it started at 3 and must then get to minus 3 when t is 9. The vehicle then immediately stops accelerating or decelerating and travels a further 33 meters at constant speed. It doesn't tell us how long, so that's for us to work out. But we now know it's doing minus 3 meters per second. It just simply means 3 meters per second in the opposite direction to the direction it started moving in. So it's doing a speed of 3 meters per second. So it's going to travel 33 meters. That will take 11 seconds to travel 33 meters. So our graph goes up to a time value of 20, and that is the end of the graph. In part B, find the distance of the car from P after 20 seconds. Well, the important thing about this journey is, first of all, it travels forwards. We can tell it's traveling forwards because this first section of the graph has a positive velocity. And then it stops and turns around and starts moving backwards. We know it's moving backwards because this section of the graph has a negative velocity. So imagine the vehicle sets off, moves forwards, it stops, and it turns around and starts moving the other way. We want to find how far is it away from P. Now P is where it started. Our strategy here is to use the area under the graph because that is the distance traveled, and we must also think about its move forward and its move backward. We need to take that into account. So let's find the area under the first section of the graph. How far did it move forwards? Well, here's a triangle with a base of 6.5. We know that's definitely 6.5 because it's halfway between 4 and 9, just using the symmetry of the graph, and the height of 3. So the area under that triangle is how far it's moved forwards, and that turns out to be 9.75 meters. Next, how far has it moved backwards? Well, here I have a trapezium. You could break it down into a triangle and a rectangle if you want to, but it's quicker to do it as a trapezium. So trapezium is half the sum of the parallel sides. So here this side has a length of 11, and the other parallel side, well, this little bit here is 2.5 plus 11 gives me 13.5, and the distance between them is 3. So the area of this parallelogram is given by this formula. For A-level maths, you should know the area of a trapezium formula. So that's how far it moves backwards, and we want to know how far is it from the start after 20 seconds. So the distance from P after 20 seconds, it's going to be the difference between these numbers. Now the question asks for distance, not displacement. Distance can only be positive. However, displacement could be negative. Displacement is a vector, but distance is a scalar. So our final answer must be positive. It's just going to be the difference of these two values. It's 27 meters. If the question had said find the displacement of the car from P after 20 seconds, then our answer would have been negative 27, because it moves forwards 9.75 meters, then it moves backwards further, so it finishes further behind than it started. That's the end of the question.